Hello, class. Welcome to Searcher TV, where learning research is made easy. This is your Searcher teacher Ian, and let's learn research for our daily lives. Today, we will be learning about quantitative data analysis. Now, this part of our research process is expected to be done towards the end, meaning when you have already completed your data collection and that you are now approaching the conclusion part of your research. So, this is also just like any other steps in your research process. Data analysis is also one of the most crucial and critical part of our research because this will now lead us into the findings and finally coming up with our conclusions that would answer our research problem. But for this lecture video, we will be discussing or we will be learning about the basic or the simple, we will learn the basic or the simple um, process, which is more on descriptive analysis. So this part, we will be expecting two parts for quantitative data analysis. So we have the descriptive data analysis, and then we will have another video for the quantitative data analysis. So let's get started. So here, remember that all these varied analytical studies that you pour into your research become significant only if prior to finalizing your mind about these activities, you have already identified the measurement level or scale of your quantitative data. That is why it is important that we have to identify and to know what kind of measurement scale the data that we gather. Since our data analysis procedures will solely depend on the type of measurement scale. Okay, so whether your study measures a data through a ratio or interval scale and not by means of nominal or ordinal scale, because these last two levels of measurement are for qualitative data analysis. So what will happen, for instance, if we have, let's say, qualitative data, but we are conducting a quantitative data. Is that possible, sir researcher? Yes, it's actually very possible. So we will be knowing or we will discover later how are we going to um, use or how are we going to process the qualitative data into a quantitative research. So let's now talk about the steps in quantitative data analysis. So there are actually how many steps do we have here? If I'm not mistaken, yeah, there are two basic steps, okay, or two parts in how we are going to analyze quantitatively your collected data. So the first one here is your data preparation. So keep in mind that no data organization means no sound data analysis. That is why prior to your data analysis in your methodology or in your data analysis plan, you have already stated or you have already emphasized uh, or listed the organization procedure or the preparation procedure of your data so that you will not find it difficult when the time comes that you have to do do it in actual or implement or organize your data once it's already available. Hence, preparing the data for analysis by first doing these two preparatory substeps. So the first substep class is what we call your coding system. Now, this is to quantify or change the verbally expressed data into numerical information. Now, remember that converting the words, images, or pictures into numbers, they become fit for any analytical procedure requiring knowledge of arithmetic and mathematical computations because basically we cannot add up words or we cannot summarize pictures unless if we wanted to set a theme. But if it's quantitative in nature, the approach is quite different. Now, but it's not possible for you to do that. And likewise, um, in order for us to have a uniform data processing in a quantitative research type, it's very important that we have to code our non um, quantitative data. Okay, so how do we do this? Okay, so for instance, you have the variable gender. Okay, I will give you an example. So let's say you have the variable gender. Mhm. So we know that gender is a okay, let's try to be more diverse and not use gender but rather biological sex. Okay. So let's use biological sex as our variable here. And as we know, there are only two biological sex. We have the male and the female. Okay. Now, how can we quantify male and female? Because in the first place, they are dichotomous nominal variable. So we have this what we call your coding system. So what we do is we assign a certain numerical value or a certain numeral or a certain number for each variable. So let's say if it's a male, we assign number one, and if it's a female, we assign number two. But remember this, the numerical representation of our nominal variables here does not have any values. Meaning, it doesn't mean that if you assign number two for female, it has more value over the number one for male. Just remember that these are just numerical representation. So that later on, if we wanted to know the if we wanted to count the frequency of male and the frequency of female, it would be easier for us to identify, and it would be easier for softwares to count because there is a numerical representation. And likewise, if there are variables that are quite long, or let's say like a particular phenomenon or a particular statement that's quite long, coding system really helps shorten those variables so that when we encode or when we classify into our spreadsheets for data processing on softwares, that would be quite easy to undertake and to yeah, quite easy to undertake, and it's not so hard to do. Okay, so that's what we do under your coding system. Now, the second part or the second way or the second process in your um, step one, which is preparation of your data, is your data tabulation. So from the name itself, we have tabulation. So that would lead us now to table here. So for easy classification and distribution of numbers based on a certain criterion, you have to collate them with the help of a table. So here we use frequencies and percent distribution. So remember, class, that for data tabulation, we use frequencies. Okay, so frequencies meaning the number of occurrence of a particular variable. And of course, we also use your percentage. So I think we don't have to discuss what percentage is because we already are familiar with that. So it's part to whole representation. Okay, so remember that this kind of graph or your table is an excellent data organizer that researchers find indispensable. So your data or your table, I mean, class, is aside from the fact that it presents, okay, it helps you organize your data, it also reflects somehow the summary of your collected data. Because as we said, we use frequencies and we use percentage. So if we place that on our table and if we see that we automatically would see, okay, so this is the variable with the highest frequency and this is the percentage distribution. So we would know right away just by looking at the table how the data are, or how the data are distributed. All right, so let me give you an example of a data, okay, of a table. Okay, so this is just one way of presenting your table here. Mhm. So we have a minimum of two columns. So the first column, or the leftmost column, mostly will be the variable. And then as it goes towards the right, it depends on how many other columns you're going to add, or how you're going to represent that particular variable. But in this case, the frequency, um, the the sub variable, which is here. Okay, let me highlight a little bit. Okay, wait. So this is now your first, your gender here is your first, your for your first column, so that's your variable. Your male and female here are your sub variables. Your number 11 and 13 here are your frequency, while 46 and 54% here are your um percentage. But in some other ways, you could make a separate column for the male and female, another column for the frequency, and another column for the district, or the percentage. But this is a minimalist take on the table. As long as all pertinent information are present, the way you present your table really doesn't matter. But pro tip, make your table as simple as possible. Don't make it too complex, because people will, or your readers will see your table in order for, because they don't want to read all those long paragraphs. So they just look into the table and see how the data are, or how the data goes. And that would help you or assist you with whatever things that you wanted to do. So that's a pro tip class. All right. I think we done with that. So that is our Tavia data tabulation. Okay, now let's proceed to step two. Now you have prepared, you already finished your preparation of your data, you're done with the coding, you're done with the tables, you have placed all of your um, data into your frequencies and assigned percent distribution. It is time for us to analyze our data. Now, remember, this lecture video will only talk about the descriptive statistical techniques, so we will cover this, okay? While on the second video, we will be covering our inferential statistics, because that's quite a lot and it's a little bit more complex. So we will have a separate dedicated video for that. All right. Now, data, the one thing that beginning researchers often use tells us the aspect of categories of data. And in here, we now begin with the descriptive statistical techniques. And your descriptive statistical techniques would cover most likely your frequency of distribution, your measures of central tendencies, and even your standard deviation. However, remember that your your descriptive statistical technique does not really give you the information about the population where the sample came from. So this is just like an overview, okay? Okay, this is just like an overview, or let's say like a preview of the type of data that you have gathered, while your inferential statistics would now make inferences, and that would now lead us to more conclusion. Okay. All right, so I think we are now ready. And because here, the second, or your inferential statistics, fits higher level of research competence, because this involves complex statistical analysis requiring a good foundation and thorough knowledge about statistics. Therefore, for a little bit more advanced data analysis, then we will be talking about inferential statistics, and we'll be learning about that. But of course, you're lucky because you're here in Searcher TV, so we will cover both your descriptive and your inferential statistical techniques. Yay. Now let's start with your descriptive statistical technique. Now, as what I have initially mentioned, descriptive statistical techniques provide a summary of the orderly or sequential data obtained through the data gathering instruments. And in here, we it includes three essential parts: your frequency distribution, your measures of central tendency, and your measures of variability. So let's take a look here. So the first one is frequency distribution. So we have already talked about tables. So this is really is the same. And usually, if during the data preparation, you have already accomplished your tables, so well and good. So this gives us the frequency of distribution and percentage of the occurrence of an item in a set of data. In other words, it gives you the number of responses given repeatedly for one question. So in here, okay, let me also show you another way of putting in your frequencies. So yes, the very basic ones we have here. Okay, wait. Okay, we have here. All right, your variables. Can you see there on the first column? Then there is a code because these variables are in words or phrases. So we have to code them. This is now your frequency distribution. I'm sorry. So how many answered strongly agree and your percent distribution. So that's also another way of putting in your tabulation. There. Okay. Next up is measures of central tendency. Now, this is a review because in your statistics and probability, you might have covered this one. But let me just walk you through one more time with our measures of central tendency. Now, remember that when we say measures of central tendency, what are we talking here? Okay, we are talking about the what? Okay, the different positions or values of the items. Okay, so positioning, but technically because it's central tendency, so the central position of your data set. And we do the following, and I mean, it's composed of the following. So we have your mean, your median, and your mode. So just a quick description for each. So your mean here, class, is your average of all the items or score. Average, okay. And this is usually done, yeah. Okay, wait. Mm-mm. So the summation, okay, I'm not quite sure, but it's the summation of your scores over and okay, well, I don't want to really put like a statistical formula for that, but of course when you do your average, you just have to add all of the scores and then you divide it as to how much or how many scores are there. Okay, so that is your mean. Your median, on the other hand, is the score in the middle of a set of items. The score, okay, in the middle of, oh, the middle of a data set. Mhm. And now for your median, okay, I'd just like to add a little input here. So, in order for us to identify the median, the first thing that we need to do is first arrange your data in an array. So, an array could be from highest to lowest or vice versa. And then if there are scores that are repeated, so let's say for example there are five number threes, you don't have to write the five threes, but just the three only. Okay, so do not write repeated numbers. So just if there's only one score but multiple occurrence of that score, just write that score in there. And usually it's quite easy to identify the median if you have a an odd array. Okay, because if you have an odd array, you just have to look at the central number or the central score. So for example, your array is 1 7 3. No, no, not 3, because it's an array. So 1 7 10, 14, 12, 18, 20. Okay, so you count them 1 2 3 4 5 6 7. Now 14 here is your median. Okay, but if you have an even array, okay, let's say you add here okay, 9 for example. So okay, one, wait, okay, so 1 7 9 10 14. Oh, sorry, the 12 and 14 should be exchanged, my bad. Okay, so okay, wait. So 12, 14, 18, and 20. Okay, so please note of this. It should be 12 and 14, not 14 and 12. So 1, 2, 3, 4, 5, 6, 7, 8. So you have a total of 8. So what you're going to do, you look into the two scores in the middle, and then you just have to add these scores and divide into 2. So these are the two middle scores, your 10 and 12. So 10 plus 12 is 22 divided by 2, you get 11. So 11 now is your median score. And of course, the mode is the most, okay, recurring score. Okay, it's the most recurring data or score. So it could be bimodal. All right. So when you say bimodal, you have two modes, or it could be trimodal. So if there are, let's say, okay, in our array, let's say there are 5, number 7, and the rest are less than 5, then our mode is number 7. Okay? There. Now let's go to our measures of variability. So we have three measures of variability here. We have your range. So, okay, what do we mean by measures of variability first? Okay, this describes the amount of difference and spread in a data set. Okay, so please take note of this. So this would now describe the amount of difference. Amount, okay. It's the amount of difference. Okay, it's the amount of difference, and at the same time, the spread in your data set. Now, this could be identified by three parts or three components. So we have your range, your standard deviation, and your variance. So how do we do this? So your range is usually the difference between your highest and the lowest score. So you identify the highest score, and then you just deduct it with your lowest score, and that's your range. Mhm. Your standard deviation, on the other hand, extent of the difference of the data from the mean. So this would now cover the extent of the data from the mean. Okay, so this would now show the extent of difference of your data from the mean. Likewise, okay, wait. Mm. Likewise, your variance is now the informal measures or of how far, okay, this is how far a set of random numbers, okay, are spread out. Now usually your variance here is okay, your variance is actually the squared of your standard deviation. So you get your standard deviation by, okay, your standard deviation is the square root of your variance. Okay? So do not forget that. Okay, let's just have a quick um run through and how we're going to solve for the standard deviation and the variance. So I'll let you show here. Okay, so the first step is, of course, you need to solve for the mean. Okay, and then at the same time, you need to the second step is compute the deviation or the difference. Okay, wait, I'll just have to here. Okay. Mhm. So the first one is solve for the mean, and after you solve for the mean, okay, after you solve for the mean, you get the difference. So if you've noticed, the data item here are in an array, but you have to include each numbers whether they are repeated or not. So it has to be stated there, very listed. Okay, so 1, 2, 6, 6, and so on and so forth. And then for the step two, you compute the deviation or difference between each respondent with the mean. So 1 minus 7. So this is now your mean here. So you get -6. You do that for the rest. And then you square the deviation. So that's step three. So technically, you'll be able to come up with all positive values here. And then once you get all the square of the deviation, you look for the sum of squares. So that's 196. And then after that, you have to get the variance. And how do we get the variance? Okay, in getting the variance, you just have to um okay, we divide the sum of squares by the number of data items. So this is 196 divided by 9. So because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, we have total 9 items. So we get 21.78. And in order for us to come up with our standard deviation, we have to square the 21.78, and that's 4.6 and 7. Okay, so that's it. Now, I'm going to discuss the relevance of your measures of variability and why is it important that we need to identify your measures of variability. So, one moment. Okay, so we will appreciate how your measures of your standard deviation would actually tell us. Okay. All right. So let's take a look here at the importance of our measures of variability. Okay. So let's take a look first at our range. So, what is the relevance of our range? Now, we know that our range class is a difference between the highest score and the lowest score, right? Okay. However, there are other factors that would affect the range of a particular data set. So we have this what we call your outliers. Okay, what do we mean when we say outliers? So for example, if the lowest score, okay, let's say in a test of in a 20 item test, okay, in a 20 item test, let's say your lowest score is 2 and your highest score is 17. Okay, let's say uh that is our um lowest and highest score. So technically our range is 17 minus 2, it's 15, right? Okay, so our range is 15. So that's quite a lot. Now, for 15, we could say that the range is very spread out, but it might be influenced by an outlier. And what do we mean by this? So let's say you have a total your population, or you have a total of let's say 10 students. Mhm. And from these 10 students, 9 of them got a score between 2 to 12. Okay. Only 9 students got a score between 2 to 12, while only one student got a score of 17. So if you've noticed, most of the students' scores are only within 2 to 12, and only one student got a score of 17. So this 17 here is an outlier. So the range is not really a very good determinant of distribution because, as what I've said, it can be influenced by an outlier, a score that deviates a lot into the rest of the scores. That's why we have to solve for the standard deviation so that we would really know the influence of outliers into your distribution, because the common sense would tell us that if your range is high, if your range is big, then your scores are dispersed, but not in all cases or not in all scenarios, because as what I've said, there are outliers or data scores that really separates from the rest of the scores. Now, what is the implication now of your standard deviation? So now let's take a look here at your standard deviation or your SD. Now, usually if you have a high SD, it means that your distribution there is a wide data spread. Okay, there is a wide data spread, and most likely your data is heterogeneous. Heter- Heterogeneous. Okay, so wide data spread and heterogeneous, varying data. The data are not really very similar with each other. While your low SD, on the other hand, we have your cohesive spread. Okay. We have a more cohesive spread, therefore giving us the impression that our data could be homogeneous or somewhat like similar with each other. So there in here you would have multiple modes because there are scores that are quite similar with each other. Okay, and so on and so forth. And probably the median would also be close to the mean because the data are not too spread out. All right. Now, what is okay? Let us put it into a more complex perspective. Not really more complex, but into a more contextualized perspective. So let's say we have here class A and we have class B. All right. So this is our example. Now let's say the mean score for both class is 27.81 and 27.81. Now just by looking at the mean score, we could say that both classes perform the same because of their mean, because of their similar mean. So both would have 27.81 as their mean. So that means that their mean is the same. So therefore, they perform similarly. However, if we looked at the standard deviation and assuming that the standard deviation for class A is 1.82, while the standard deviation for class B is 2. Let's make it bigger, 3.47. This will now tell us that, okay, even though the mean scores are the same, there might be some difference. Why? Because as what we've said, the lower the SD, the more homogeneous or the more unvarying the scores are as compared to a high SD. So if the standard deviation is small, meaning the students' scores are really close to the mean, so most of them are somehow performing quite the same, or their level of their performance is also quite the same. There are less outliers. There are no extreme scores that really deviates from the mean. So therefore, we can probably conclude that class A performs better than class B because the scores are more closer or are closer to the mean compared to the scores of class B. It might be that in class B there are really very good performing students who got really high scores, but then they try to pull the other students with low scores. That's why they achieve that kind of mean. Okay. So I think that quite makes sense, and I hope you have understood that. Okay, so I do hope, class, we have learned something today. And please, if you have any questions regarding our measures of central tendencies and measures of variability, or if you have some disputes or arguments regarding our lecture discussion, please feel free to comment down below and I will look into it. And if there are some lapses or clarifications or any content that was not properly discussed or any enhancement contents as well, just comment it and I will create a dedicated video for that. So once again, this is okay. So don't forget to hit like to this video, subscribe, and ring the notification bell for new contents weekly. So this is once again your researcher teacher Ian saying class dismissed. Thank you and see you next time.